Today, we're going to be taking a quick look at carbohydrates and the techniques involved with cooking with them. Now, to understand carbohydrates, we need to understand how they're built. To start, plants make energy via a system called photosynthesis. To store that energy, the plants turn the energy into sugar. Now, the best way to think about these sugars, and how we're going to be talking about them today, is to think of them like batteries. Now, at the very top of the chain, we have a simple sugar called glucose, most commonly found in plants, probably one of the most well-known sugars. And today we're going to be using a AAA battery to discuss that. Next, we have fructose, or fruit sugar. We're going to be using a AA to talk about that. And finally, we have what's called galactose, which is usually found in milk and sugar beets, and we're going to be using a D battery for that. These are all called monosaccharides, meaning they only have one molecule. Now, if we mix some of these monosaccharides together, we get disaccharides, meaning double sugars. Now let's take an example. If we start with our simple sugar, glucose, our AAA, and we mix it with our galactose, our D battery, we get what's called lactose. You may be familiar with this. A lot of people are lactose intolerant. However, if we switch this out and we keep our glucose and we mix it with our fructose, we have sucrose, which is what we use for table sugar. Lastly, if we take two of the AAA batteries, the glucose, and we mix these two together, we get what's called maltose. Now, if we take these and we chain together several thousand of them, we get what's called a polysaccharide, which is what we're going to be dealing with today. For example, if we chain together several thousand of these glucose molecules into a very long branch, we get what's called amylose, which is a form of starch. However, depending on how these branches look, we get different types of starch. Now, if we take this same chain and we break it apart into a tree-like looking molecule and kind of rearrange it, kind of shorter, bulkier, we get a starch called amylopectin. Now, even though these are made out of sugar molecules, they don't actually taste sweet to us because our tongue is not complex enough to be able to taste them. However, the shapes of these starch really change how we cook with them and how we use them. Depending on what starch we're looking at depends on how much amylose and amylopectin are in each one of them. Now, what this means is the percentage of and the type of starch they have in it is going to change how we interact with these starches. For example, when we're using wheat starch compared to with potato starch contains a lot more amylose to where wheat starch contains a lot more amylopectin. Now, what this means is the potato starch has a much harder time thickening. It requires much more starch to thicken the same amount of liquid that a wheat starch would need. Today, however, we're going to be using rice. Rice is a great example of these carbohydrates because different types of rice have different ratios of amylose and amylopectin in them, and because of this, it changes how we cook with them. Now, the three different types of rice, we have a long rice, a medium rice, and a short grain rice. Long grain rice, which I think most people are more familiar with, has a lot of amylose in it, but very little amylopectin in it. Now, what this means is long grain rice usually cooks up very soft, very fluffy, but very separate from one another. This is because amylose doesn't release a lot of its starch. Medium grain rice, however, has more amylopectin than long grain rice, but still has mostly amylose in it. Now, what this means is it still cooks soft and fluffy, but it gives up a little bit of its starch while cooking. We usually use medium rice in rice pudding, as we want a little bit of the starch to be released. Short grain rice, however, what most people are familiar with is arborio rice or risotto rice. Now, we use this rice because it contains a lot of amylopectin and just a little bit of amylose. And what this means is because it has a branching structure, if you'll remember, it rubs up against each other a little bit better, and instead of rupturing the starches, it releases more starch. Now, if you're familiar with the risotto, you constantly stir it, and what this is doing is it's creating friction that's releasing starch into the liquid around it, and this creates our sauce. This is all because short grain rice has much more amylopectin in it, which releases starch much better than amylose does.